In this example, we're going to look at how to find the stationary points on y equals 2x cubed and determine their nature, whether they're a minimum turning point, maximum, or rising or falling points of inflection. Firstly, what you do is you differentiate to get 6x squared, multiply down and reduce by 1, and then make your statement stationary points occur when the derivative or the gradient is equal to 0. You let 6x squared equal 0, since the gradient is equal to 0. We then divide by 6 and square root, and that gives x equals 0. This is the x value for a stationary point. We need to find the y value, so you substitute x equals 0 back in to the original function. So y equals 2 times 0 cubed, which is just 0. So our stationary point is 0, 0. We then draw our nature table. The x value of the stationary point is 0, put that in the middle. We look at just before 0 to see what's happening, and we look at just after 0, so we'll use 1 and negative 1 again. At x equals 0, the gradient is 0. We then have to see what's happening at negative 1 to the derivative, see if it's positive or negative, and we then have to look at 1 to see whether it's positive or negative, and then we can work out what the slope's doing. So at x equals negative 1, we'll substitute that into the derivative. The derivative is this value here, 6x squared. So 6 times negative 1 squared equals positive 6. Then we'll substitute 1 into the derivative. So same idea, substitute it into this part, and you get positive 6 again. So we have a positive here and a positive here. So that's an upward slope, a flat, and an upward slope. So this stationary point is a rising point of inflection, and it happens at 0, 0. And if we were to look at that on a graph, it would look like this. Stationary point here, which should be over a wee bit, at 0, 0, and it's a rising point of inflection.